Welcome everyone to my video presentation. Myself, Mridul Ghosh, Assistant Professor of Sampur Siddheshwari Mahavidyalaya. I would like to present on my topic a deep learning based approach to single mixed skip type identification. The co-authors of my paper, Gaurav Baito, Dr. Himadri Mukherjee, Dr. Sheikh Obaidullah, Dr. Kosi Roy. With the rapid advancement of information technology in all facets of our life, our dependence on digital world is significantly growing. Along with this, multi-script character recognition is necessary to read word from different document for a country like India. Before script identification, script type classification is necessary since nowadays the scene text in natural images are not only comprised of single script but also multi-script words at character level are found very frequently in different places like restaurant hoardings, banners, posters, t-shirt graffiti, etc. So script identification acts as a precursor in recognizing the scene text by optical character recognition, OCR. Depending on the script form, the documents can be broken into three major types. A whole document can be written in single script. A document can be written in two or more different scripts. That is, some parts of the document are written in one script and the remainder section written in another script. The words in the document are itself written in two or more different scripts. In this paper, we have encountered number 1 and number 3. That is, we consider the single script scenario and we have considered the mixed script words, that is the word itself containing one or uh, more than one different scripts. Proposed method, we have used deep learning based architecture. As we know, deep learning based approach was employed for employed in this work to classify single and mixed script class images. Deep learning is a technique under machine learning which replaces handcrafted feature concept. In deep learning, images can be directly fed to the network and the output can be generated uh, or the classification result can be generated from the output. So among different deep learning framework, convolutional neural network or CNN is very much popular due to its ability to work on spatial data. In a CNN, there are three phases. One is convolution, one is pooling, and another is fully connected layer. In convolution layer, the images are convoluted by a filter or, or a mask, and the which is slided through the entire images, and the features are produced. Last layer, that is the dense layer, where there is a all-to-all connection between the neurons and helps in classification. There are two types of function, activation function are used. One is softmax activation function. Beta is equal to e to the power s1 to f summation 1 to f e to the power s, where s is the input vector and f denotes the length of the vector. And another is ReLU or rectified linear unit, which is Ri equal to max 0 I. That is, if it is less than 0, then Ri will be 0, and otherwise it will be Ri equal to I. So you can see this is a proposed CNN framework. We have used two convolution layer and two max pooling layer and two dense layers. The first convolution layer contains a 32 filters and the filter dimension is 5 by 5. The second convolution is 16 by 16 filters and 3 by 3 is the filter dimension, and the max pooling dimensions are 3 by 3. And first fully connected or dense layer is 256, and the output layer or the second dense layer is 2 or 3 depending upon the output class. So this is our proposed framework where input image is directly fed to the convolution layers, first convolution layer. These are the generated parameters uh, for each layer. In the convolution 1, there are 2432 number of non-outlier set, and for the outlier set there is 2432, same number of parameters generated, except for the FC1 fully connected 1 and fully connected 2, there are different values, and the total parameters are shown here. The data set. The data set is imperative for any research work. For the single script images, we have taken images from CBSI 15 video script dataset. CBSI 15 is a dataset where there are 10 different classes of images are there. Different classes, or you may say different scripts images are there. The mixed script images were captured from different sources like, as we said, t-shirt graffiti, hoarding of restaurant, movie posters, banner, etc. So there are 1350 numbers of single script images and 1349 numbers of mixed script images were collected. In an outlier, a single script class, we have collected 1351 numbers of index scripts, that is Gurumukhi, Kannada, Gujarati, Tamil, Telugu, Odia, and Arabic, which are taken from CBSI 15 dataset. It is the outlier set is used to show the robustness of our method. So this is the sample dataset. In the first layer, that is in the single script images are shown A to E, the single script images. Second layer, second row represents the mixed script images which are collected from different sources. You can see the images where the first one is combination of Bangla and Roman. Second one is combination of Roman and Bangla. Third one is Roman and Bangla. Fourth one is Devanagari and Roman and Devanagari. And fifth one is Roman and Devanagari. In the outlier set, the first one denotes the image for Arabic image. Second is Odia image, Kannada, third, and Tamil in the fourth, and Telugu in the fifth. So this is the result. Actually, we consider the data set in two parts. That is the data set which contains the outlier set, and the data set which doesn't contain the outlier set. So for both the data set, we have calculated the accuracy. From the table, you can see for the non-outlier set and the outlier set. And since we have collected from different sources of images, that there are disparity in image sizes. So since there are disparity in image sizes, we have considered the images from 25 size 25 to 150. We have resized the images 25 to 150, and for each image size we have calculated the accuracy for these two sets. And you can see image size 1 to 5, the accuracy is highest for the non-outlier set, that is 98.30, while for 100 it is highest for outlier sets, 95.888. We have explored the confusion matrix for the outlier set without outlier set, for the highest accuracy, that is 98.30, and we can see there are 7 images were misclassified to biscripts from single script, and 39 images were misclassified to single script from biscripts. Also, we have analyzed the confusion matrix of the set with outlier. We can see there are 60 images misclassified to outlier set, while only one image are misclassified to biscript. So these are the few misclassified instances. In the first row, that is A to E, the images were misclassified to single script. So these are the mixed script classes. So misclassified to single script uh, due to noise, due to blurriness, for these reasons. In the similar reasons, uh, for in the second row, the images were misclassified to single script class, misclassified to mixed script class from single script class. And the third row, the images are misclassified to a single script class from outlier. So the reasons are there are small size image issue already there. G, H, J, L, these are the small size images, and K also, K and M also. Also, there is a blurriness. You can see image F, image O, image L, image D, EC. These images suffers from the blurriness, haziness, and noise. Okay. We have compared our method with the state of art, that is the Inception V3 network. Inception V3 is a 48 layered deep network, and we have only 7-layer network. So using 7-layer network, we can see our result is very much encouraging compared to Inception V3. So this is the result, the comparison result for the set without outlier, and this is the set with outlier. All the cases we can see, uh, you can see the average case, our result gives the best accuracy compared to Inception V3. Also, we have extracted hand-encrypted features for without layer, outlier and with outlier set, and we have used LBP, HOG and WLD feature extractor, well-known feature extractor, and we have used machine learning, well-known machine learning classifiers like simple logistic, random forest, and decision table. We can see for decision table, LBP gives the for random forest for almost all cases. We are getting the good accuracy, which is highest is 97.23 for non-outlier set, and for outlier set we are getting 93.24. Compared to our method using CNN based method, our method gives a good accuracy compared to hand-encrypted features. On network, the complexity becomes LI-FI, order of LI-FI, CI-FI, summation 1 to n, where n denotes the number of convolution layers. Ci and Fi represents the number, C and Fi represents the number of channels, and Fi is the number of filters or the ith layer respectively. The time complexity of simple logistic can be represented as order of m, where m denotes the number of attributes. For random forest, order of m into n log n runtime complexity, where n denotes the input data. For decision table, order of PL, where P denotes the number of nodes for the graph and L represents depth of the graph. The space complexity means the number of input data resides in the memory. Mm. So it almost same for all the cases. That is order of n for all the cases. Conclusion: in future, we will more multi-skip classes will consider, and corresponding skip identification system will be built. We will also increase the volume of the data set by considering data augmentation methods. To increase the consistency of the device, procedure like denoising, deblurring, etc. will be tailored. Also, the low illumination and small word issues will be taken into account. We are planning to develop a shallow deep learning method to make the work to be worked on the low resourced platform. Also, different deep learning frameworks like soft computing based on paradigm based on soft computing, active learning, and ensemble of conjoint networks will be considered to enhance the result. These are the reference. Thank you for patiently listening me.